So I got your email for your homework.
Yeah. It's like it's the same thing, but we have a quiz tomorrow. So I just like wanted to like go through everything again.
Okay.
Like just the
Uh,
yeah.
okay. So with the graphing, there's a really good example right here on number 4,
Oh yeah. Oh,
where you just create a t-chart for x, and then you just plug it in as the exponent every time, and then
okay.
just solve it on a calculator.
Okay. Also, for like one of the I think on it was on homework 7-3 on number 21. Okay, so I like did that graph and then my teacher, we were doing our homework in class and he just like randomly came over to my desk. It was like really weird. I was like talking to my friend and he just like stands behind me and I'm like, what is happening? And he's like, this is wrong. But it was like it was I don't he said to do it that way, but like that way just makes absolutely no sense.
Which way did he say to do it?
Let's do it. Okay, so like what he wrote, that's or that's like how he wants you to do it with like this like 1/b and then like one and then another b, but then the 1/b you like flip it or something.
Okay. So x minus 2 equals 0, x equals 2, h equals 2, and then so x has to be plus 2 and b has to be 2. So it was, so everything he wrote is blue and red, right?
Yeah, like everything. Well, that because yeah, that's like just like he did that problem himself.
Okay, so it's the base of 2. Okay, so it's 1 over the base, so it's like why it's 1 over 2
Okay.
plus 2, and then it's 2 times 5, and then 1 plus 2, and then 3. I don't know. Well, I guess from not seeing him talk it out, like he wants you to work with the base, 1 over the base, and then 1, and then the base.
Yeah.
Okay, and so you end up with -1, 0, 1. But
Yeah.
the graph that we did was the exact same, regardless.
Yeah, and like that made so much more sense. Like I don't know. Like it's so I don't get it.
It's
Like
okay.
it's not
Then what I suggest is just create a t-chart, and what he wants you to do is he wants you to do 1 over the base, 1, and then the base.
okay.
So the base here is so when I say base, this is read as log base 2. So it's like this right here. So it would be 1 over the base plus what x is to get 0, because you want to do that, and that would give you -1, and then 1, just 1, and
Okay.
then 1 plus whatever x is to give you 0, and then the base. So
Okay.
every time you're going to add 1 over the base and then plus whatever makes x 0.
Okay.
So it's going to be like plus whatever x is, and then it's going to be 1 plus x, which this is not a color you can see. I'm going to change it back to red.
Okay.
So you have 1 over b, and then plus, so 1 over the base, whatever the base is for your log, and then 1, and then it's going to be your base plus x. And that's what you're going to do. And that's going to do it. And then you put it in there and you get your answer. Very similar to what we were doing, except we were choosing whatever we wanted. So instead of choosing like 0, like instead of choosing 2, 3, 4, 5, like we did 2, 3, and 4, you would just do it this way. These are the numbers you would work with. Very, very similar to what we did, except you're going to rely on the base, whatever the base is. And you're going to do a 1, like we always do, and
Okay.
then you're going to do the base.
What was like different from like this and what you did?
Yeah, I do a t-chart where I just choose random values for x
Yeah.
and then plug it in. And as long as you can plot some of those points on the graph, because we know what the graph is going to look like.
Okay.
Like we know that the graph is going to be, it's going to be one of those weird curves like this, where it gets super close to y but never actually touches it, and then it extends. We know it's going to look like that, and so as long as we have a couple points that get us close to it, we're good to go.
Okay.
Yeah. So that's pretty much all it is.
Okay.
Let's look up and make sure that you're still doing these properly.
Okay.
Um,
Oh yeah. So number 7. Can I see? Oh wait.
so
Can I see if I remember how to do it?
yeah, which one do you want to do?
Okay. I guess we could do number 1. Okay. So write each
Can you see it?
Okay, yes. Okay. So write each equation in an exponential form. Okay. Okay. I'm like nervous about my quiz because I can't use my notes because I'm taking it in the classroom with my classmates. So like I just have to remember all the rules here. But okay. So oh yeah, it's okay. Wouldn't you do would be like 216 like x equals 3 and then 6 is your exponent.
Well, close.
Okay.
We're gonna
Okay.
take 6 and we're gonna put it to where 216 is. 216 goes to 3 and 3 becomes the exponent. So this is gonna become 6 cubed equals 216.
Okay, equals 2. Okay, okay.
We took the base and made it the regular number, and then 3 became the exponent, and then 216 got moved to the other side. And if you were to use a calculator
Okay.
and you type it in, 6 cubed is in fact 216.
Oh, okay. Oh, because you would do the thing where you have to like break up 216.
If we wanted to solve it, but we don't have to.
Okay.
Because we have no x's in the exponents, so we don't actually have to worry about it.
Okay.
That
Okay.
was from 7.2.
Okay. So
which
then,
we'll go over that in a minute.
okay. So for like number 2, it would be so you would, I'll go here. Okay, so it would be 2. Wait, no. 6 equals 64 cubes.
Well, it's again the base for the log is going to become the number you start with. So the little 2 became a big 2, and then the number that's on the other side becomes the exponent to that, and then this number gets moved to the other side. So this is 2 raised to the 6th power equals 64.
Okay. I'm like trying to do it where I like don't look at my previous problem to see if I remembered it. Okay, this is just we're gonna memorize this. Okay. So like for 3, it would be 3 equals.
I need to move the screen over a little bit.
Okay. So
equals
negative 81 to the negative 4th power.
Well, it's gonna remember the base is what we start with.
Shoot. Okay, I start with 3.
You start with 3, and this becomes a new exponent.
Oh, because that one goes back over there. Okay. Oh, yeah. Okay. So 3 negative 4 equals negative 81.
1 over 81.
Oh, got it.
Because when you have a negative exponent, to make it positive, you just have to move it to the denominator. So this is 1 over 3 to the 4th, and 3 to the 4th is 81. So they're going to still create true answers.
Okay.
Yeah.
Okay. So that is okay. Okay. Can we do? I'm gonna do number 1 again, just to like really make sure I got that. Okay. So it would be okay. So here, this here. Okay, so it would be 6 cubed equals 216.
Yes, ma'am.
Perfect. Okay, I think I got this. And then so for 4, isn't that like it's like shoot. Oh, it would be the same thing.
Yes, ma'am. These are all going to be functioning the same way because they're all logarithms.
Got it. Okay, so it'd be 10 to the negative 5th power equals 0.00001.
Yep.
All right. And then for 5, it would be 25 to the 1/2 equals 5.
Yep. And when you have an exponent like this, it's the same thing as saying the square root. So when you have 1/2, that would be the same thing as saying the square root of 25, which is why we're getting 5 as the answer.
Got it. Okay. So, okay. So then for 6, it would be 32 3/5 equals 8.
Yep.
Okay. Sweet.
Yep. Very good.
Okay.
You see all the answers? You good?
Yeah. And I wrote them down too on my, because I just
Okay.
copied my homework. Yeah.
All right.
Okay.
So now we're going to take these and we're just going to go in reverse. We're going to do what we just did, and we're going to turn these into logarithms.
Okay.
So 5 becomes the base.
Okay.
So you're going to create the log, and 5 is going to be the base, so it's a little number, and
Okay.
the 3 and the 125 move. This is log base 5 of 125 equals 3.
Okay. So, okay. Okay, so log base 5 of 125 equals, oh,
Yeah, because the 5 becomes the base of the logarithm, and the
okay.
3, the exponent, becomes the answer, and then 125 becomes what the logarithm is about.
Okay, so, okay. So for like 8, it would be, okay, so it'd be log base 7, and then a 1 equals 0.
Yes, ma'am.
Okay. And then 9, it would be log base 3, and then 81 equals 4.
Yep.
All right. Then for this one, it would be log base 3, 1/8 equals -4.
It was 1/81, but yeah.
Oh, that's what I meant. Okay. And then for 11, it would be log base 1/4, and then 1/64 equals 3.
Yep.
For 12, it would be log base 776. No, 7,776. And then it would be 6 equals 1/5.
Yep.
Okay. 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 And then, oh, this one is you have to figure out what it equals.
Yes. So in order to do that, what we're going to do is we're going to create an exponential function, and that will help us figure it out. So for instance, here, you recreated 3. You recreated it, and you made 3 raised to x equals 81. Well, 81, we know is probably going to be a factor of 3. So 81 is 99, which gives you 3, 3, 3, and 3. So
Yeah.
81 is actually, so we had 3 raised to x equals 3 raised to 4. So therefore, x equals 4.
Okay. So
Because
then, like,
when they have the same base, we can assume the exponents equal each other as well.
okay. So then, like, for 14, it would be 10x equals 0.0001.
Uh-huh.
And then you would have to figure out, well, how would you like
This
do
is going
that?
to be similar to scientific notation.
Okay.
So how many places do we have to move? Do we have to move the decimal place to the left or the right?
On the right.
Right. So you've got 0.0001. So we're going to move it 4 places to the right.
Okay.
So that's the same. So that was, however, we still only got 1. So I need to make it 10, right?
Yeah. Oh, okay. So you do
Yeah, I
it.
need to make it 10. So I moved it 5 places to the right, which means it's raised to the -5th power. So then we have 10 raised to x equals 10 raised to -5.
Oh, okay.
And then they have the same base, so we can assume the exponents equal each other. X equals -5.
Got it. Okay.
Now, what's really convenient about number 14 is if we look up here, You already had the answer from number 4.
Oh. Oh.
So, yeah.
Oh. That's so true.
Yeah, so we could verify it. That yes. So same thing. It was 10 raised to negative 5 equaled 0.0001. So coming down here, it was a problem that was similar.
Cool. Oh, and same with like 13 and 3.
Yes.
Like, I know like 1 over 81, but it's
same answer.
Yeah. Okay. So then for 15, you would do 2x equals negative 16, right? Because
it's 1 over 16. So what we'd have to do is we'd have to change 1 over 16 to 16 raised to negative 1 because we moved it from the denominator to the numerator. So now the exponent is negative.
Oh, okay.
And now what we'll do is we'll take 16 and we'll break it down into all of its factors, which are 4 and 4. And 4 breaks into 2, 2, 2, and 2. So we have 4 2s. And then what's 4 times negative 1?
Negative 4.
Right. So then we're going to do 2. We're going to do 2. Oh, that's an ugly color too. Let's try. I want to try something more fun. You can actually see. Okay. 2 raised to x equals 2 raised to negative 4. Because we had 4 2s, so 1, 2, 3, 4 times the negative 1 we had, which is why it's negative 4.
Okay.
Yep. And then, of course, they have the same base, don't they?
Yeah.
So then we can assume the exponents equal each other. X equals negative 4.
Okay. 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 So then, like, so for 16, it would be, so you would do 1 x equals 27, but then you would also do the 3 and then negative 1x equals 27. And then you could do 27 and then 9 times 3 and then 3. So then it would be 3 negative 1x equals 3 cubed. And then you would you multiply so it would be x equals negative 3?
Yep.
Okay.
Well done.
Thanks.
You're welcome.
Okay. Wow.
All right. So let's look at 7.2.
All right.
If I can get there. Okay, 7.2 is going to be very similar to what we just did, except it's going to be more complicated.
Okay.
So here you have to take it and create the same base, and then you're going to use equations to make that. So 64 is 8 and 8, right?
Yeah.
Which becomes 2 and 4, and 2 and 4, which 4 becomes 2 and 2. So how many 2s do I have? 1, 2, 3, 4, 5, 6.
Yeah.
So 64 becomes 2 raised to 6 times x minus 3. And then we know that 4 is 2 squared, right?
Yeah.
That's going to come the base of 2 raised to 2 times x plus 35. At this point, I now have bases that are the same.
Yes.
So then we can assume the exponents equal each other. And so what we'll do is we will do 2 times x plus 35 equals 6 times x minus 3. And now we'll just solve that equation.
Okay. Oh, so then it would be 2x plus 35 times 70 equals 6x minus 18. So then you would do plus 2x plus 2x plus 18.
Why are you adding the 2x?
Oh, don't you like bring it to the other side? So like you would do.
Yeah, we want to subtract it because it's positive.
Oh, that's what I meant. Anyways, okay. Yeah, so then you would do so 88 equals 4x, and then you would divide by 4. So then it would be 22. So x equals 22.
Yep.
Cool. Okay.
All right. You want to try number 2 on your own?
Okay. So, okay. So this is the same. Okay, so it'd be 64 and then -1.
Yep.
And that you could make 8. So it'd be 64. 8 times 8, so it'd be 8 with the square root of 2 plus -1. Or what do you tell me?
It's going to be all multiplied. Yeah.
So it'd be -2. And then
Yeah, we can do that.
0.5x minus 3 equals 8. 9x minus 2. So it'd be 8 and then -2.5x plus 6. So then you would do -2.5x plus 6 equals.
What is 2 times 0.5 though?
Oh wait. 1.
Yeah, so it's -x plus 6 equals 9x minus 2.
So then you would add 1x to 9x, and then you would add 2 to 6. So it'd be 8 equals 10x. Divided by 10, divided by 10, so then x equals 8 over 10.
Can that be reduced?
Yeah, you could do 4 over 5.
Yes, ma'am. So x equals 4 over 5.
Okay.
All right, let's take a little break because we were right in the middle.
Okay.
All right. So, did you have tennis today?
No, I didn't. I was supposed to have it Tuesday, but I think like our times got like mixed up or something, so I ended up not having it on Tuesday. But it's okay. It's been a good break. So, yeah.
Oh yeah, 3 will be easy because you already have a point base. So.
Yeah. So it'd be 3x minus 4 equals 3 squared x plus 28. So it'd be 2x plus 56.
Mm-hmm.
So x minus 4 equals 2x plus 56. You can bring the 2 to the other side, so you minus it. Add the 4. So it'd be -3x equals 60.
1 minus 2 is -1.
Oh, shoot. Don't know what happened there. I always like make really stupid mistakes. Like it's something I do best. Okay. So it'd be x equals -60.
Yep.
Cool. That was definitely easy. Okay. Oh, okay. Can I do number 4? Because it's I think I did something like that, but I just want to like make sure I like totally know it.
Oh yeah, go for it.
So it'd be 4 to the -1 power, and then 2x plus 2 in parentheses equals, it'd be 4, it'd be 4 cubed x minus 1, so it'd be -2x minus 1 equals 3x minus 3. You bring the -2 to the other side, and then bring the 3 to the other side. So it would be 2 equals 6x over 6. So then it would be x equals 2 over 6. And you can reduce that to x equals 1 over 3.
So So I had negative 2x minus 2 equal 3x minus 3.
Negative. Wait, can you say that one more time?
So when you distribute the negative 1, it should have been negative 2x minus 2 equals 3x minus 3.
See, this is what I always do. Like, I always, like, so bad. Like, I know it's negative 2, but I put negative 1. And I always, like, get things wrong because I do that all the time. Okay.
That's okay. It happens.
So it would be, okay. I'm just, like, erase everything else because that is going to change my answer. Okay. So it would be, oh, so it'd be x equals 6.
Well,
oh, wait, no, 1. Negative 1.
So 2x minus 2 equals 3x minus 3. When we add 3 to both sides, negative 2 plus 3 is positive 1. And then when you add 2x to both sides, 3x plus 2x is 5x.
Wait, can you, like, write it? I think I'm doing, I don't know. Like, I know what I'm doing, but something is just, like, not quite right. But I think it's...
So we're gonna take this and set it equal to this.
Yeah.
So it gives me negative 1 times 2x plus 2 equals 3 times x minus 1. So I distribute the negative 1 and then distribute the 3. And I end up with negative 2x minus 2 equals 3x minus 3.
Okay.
So I'm going to add 2x to both sides.
Okay.
Which gives me negative 2 equals 5x minus 3. And now what I'm going to do is I'm going to add 3 to both sides. So plus 3, if I can have room, plus 3. Negative 2 plus 3 is positive 1. So I end up with 1 equals 5x. And then to get x by itself, divide both sides by 5. 1/5 equals x.
Wait, okay. So I have that too. Okay. Because I have, like, the negative 2x minus 2 equals 3x minus 3. And then I added the 2x. So then that would be... Oh, wait, I wonder if I was, like, multiplying somehow.
I think you did multiply.
Sometimes everything just, like, blurs together.
No, it happens.
Okay. Yeah. Okay. Did you get negative 1? The one you first did it? Because
Nope.
I have negative 3 plus 2.
It's positive 1.
Oh, wait.
Oh, it depends on what you're doing.
Because, like, I have negative 2x minus 2 equals 3x minus 3. And so the negative 2 I brought to the other side, and then I got 5x. And then oh, wait. Oh, my God. Everything is just crazy right now. Oh, shoot. Yeah, so 1. Yeah. I think I just got, I don't know, just some numbers were just not right there. Okay.
That's okay.
Yeah, I get
There's
it.
a couple more.
Okay, yeah, so for 5, it would be 2, negative 1, x minus 3 in parentheses, and then it would be equal to 2 times 2 times 2. Wait, 2 times 2. Oh, wait, 2 times 2 times 2. I'm, like, doing my calculator, but it doesn't, like, count how many times I do.
Well, you can also factor it like I just did.
Okay. Oh, yeah. Okay, so
you just factor it and you end up with 1, 2, 3, 4 2s.
So okay, so 2, and then 4, 3x plus 1. So then we negative 1x plus 3 equals 12x plus 4. So then you do minus 3 minus 12x. 3 negative 13x equals 1. So I have a negative 13 So the x equals negative 13.
X equals negative 1 over 13.
Yeah, that's what I meant. Okay. Okay, I think I get that.
Okay, so you don't want to do number 6?
Maybe I think we could get most of it. Yeah.
Okay.
Okay.
So you're good? Okay.
Yeah.
All right. So, okay, so I see at the bottom of this page we have some inequalities with these.
Okay.
What's the only rule that's different for inequalities?
Oh, don't you have to make the 400 I don't know. I don't know if this is a rule, but you have to make the 400 basically have to do what you did on the last thing.
Yes, except but since we're dealing with inequalities, just be careful. If you multiply or divide both sides by a negative,
Oh,
you need to change the inequality symbol from greater than to less than, or vice versa.
okay. Yeah, I remember that.
But
Okay.
these would be solved the same way. Just make sure that whatever side x is on, x is either greater than or less than, as long as you just keep track of it.
Okay, got it. Okay.
But it's the same style.
Okay. So you would do okay.
Do you want to do one?
Sure. Yeah. I'll just do one because I think for 13 you would do okay. So if you started with the 1 20th, it would be 20 negative 1 7x plus 8, which would be 20, and then negative 7x minus 8, and then 400 you would do. Okay, I'm just gonna do the tree thing.
I mean, that's going to tell you it's 20 squared.
Oh, 20 squared. Okay, so it'd be 20 squared, and so then you do 2 is greater than negative 7x minus 8. So then you would add 8. So it'd be 10 is greater than negative 7x divided by negative 7, and then you switch the sign. So then it would be 10 over negative 7 is less than x.
Yes, that's correct.
Perfect.
That's how you would do that. Good job. Okay, so you know what you're doing.
Yeah.
Okay. All right, so 7.1 was some graphs.
Can I see if I remember how to? I think
Yes.
okay. Okay, so you would do x, and then you would do 1.5, 2 in parentheses, x, and then y. So then you would do, I think you could do 0, 1, 2, 3, and 4.
Well, it doesn't matter if we do negative or not, but if you do negative, you just got to make sure that you
Oh,
type in your calculator right.
so you could do negative 2, 1, 0, 1, and 2. So it would be negative 2 times 2 is negative 4. And then
What are you doing?
negative 2. And,
Oh, okay.
I did here. I'll write it how you wrote it. I did the same numbers, but it's not in that order, but I'll do it in that order.
Oh, okay.
Okay. Okay, so you do 2 times 0 is 0. And then 0.
Well, x is an exponent, so there's a particular rule when it comes to exponent rules as 0. It's 1, yeah.
Yeah, okay. So you do 1 times 1.5 is 1.5. So
Yep.
you're going to be 1.5. And then you would do 2 times 1 is 2. 2 times 1.5. Shoot, wait. 2 times 1.5 is 3. I did that right. And then you could do 2, so that would be 4, and then 4 times 1.5 is 6. And then you do negative 2, so that would be negative 4, and negative 4 times 1.5 is negative 6, and -2. -2 times 1. Oh, you already did it. -3. Oh, wait, no, you didn't. That was okay. Anyways, okay, so I got 1.5, 3, 6, -6, and -3. So you would do 0. Oh shoot.
So when x equals 0, what did y equal?
1.5.
Okay.
And then
when
I
x equaled 1, what did y equal?
got 1 I got 3.
And then when x equaled 2, y equals 6. Okay, when x equaled -1, what did y equal?
-3.
So did you type it in your calculator?
Wait.
Because that would have been 1.5 times 1/2.
Wait.
Because you would have had 2 raised to a negative exponent, and so you need to move it to the denominator. So then you have 1.5 divided by 2.
Oh. Okay. Wait, okay. Okay, so it was 1.5 and then 1. Would it be -1/2, or would you just keep it 1 positive?
Well, 2 was raised to -1, so I made it a positive x1 by moving it to the denominator.
Okay. Got that. Okay, so wait, see, okay, so do 1.5 divided by 2?
Yep.
0.75.
Yep, 0.75. And then same thing, when it'd be 1.5 times 1/2 squared. Because it was 2 raised to -2, so to make it a positive exponent, move it to the denominator. So now it'd be 1.5 divided by 4.
So it would be 0.375.
Yep, so now we plot those on the graph. So when x equaled 0, y equaled 1.5. When x equaled 1, y equaled 3. When x equaled 2, y equaled 6. When x equaled -1, y equaled 0.75. When x equaled -2, y equals 0.375. So you can see how the dots are connected.
Yeah.
That means it's going to get really close to the y-axis, and then we're just going to connect it with a curve. It's going to look like that.
Okay.
It will never actually cross the x-axis, ever. But it will get super close.
Okay. I have a question. So for like number 4, when my teacher
Number 4, you said?
Yeah. When my teacher did it, he why did he put -1.5? Would for one of his x's.
He just felt like it.
So he didn't actually have to do that?
No. They're arbitrary.
Okay.
Yeah.
Okay.
Like I think because he just knew it crossed through it. And so he just went ahead and changed. He just went ahead and did it when x equal 1.5. Because it's not like y gave you anything fancy.
Yeah. Okay.
It wasn't an easy spot for it to cross through.
Okay.
So also the graph, I'm gonna be honest. If this is your teacher's work, you have 0 when x equals 0, y equals -3. But up here, x equals 0 and y crossed it at -1.
Oh, so he did it wrong.
Well, he might have just drawn the graph wrong. Like he might have just put it in the wrong location.
Oh.
But it's just one of those things. Or it could have been you copied it down wrong. I don't know. I'm not there. I don't know what's going on.
Yeah, no, that's handwriting.
But the x values are literally whatever you want, as long as when you connect the dots, you can predict where the rest of the graph is going.
Okay.
That's what T-charts are all about. Until you actually figure out how to interpret the graph without doing a T-chart, because there is a shortcut to doing these because we recognize our exponential functions. So essentially, it's like this is essentially like having a parent function. We can tell what's going to happen. We can tell if it's going to move left, right, up, or down. But for now, we're just going to stick with the T-chart.
Okay.
Yep. So what was your question on number 4? Oh, why
no.
you chose 1.5?
Yeah.
Because he knew where the graph was going to cross. He just grabbed it because he could.
Okay. Got it.
Yep.
Okay. So like for like number 6, since it like looks a bit harder, you would just do
Yeah, well, because if x equals 0, you're going to end up with 3 raised to 4. 1/2 times that. What 3 raised to 4 is 81, and half of that is 40.
Okay.
So then you're gonna so it's gonna cross the y-axis at 35.5. That does nobody any good.
Okay.
So you're probably gonna want to go with things that are gonna limit that. So you're probably gonna want to start with -4.
Okay.
Yeah, so that way we can see what's going on. So if you start with -4, that would make that exponent 0. So you just have 1/2 minus 5, which gives you -4.5. So that'd be like easier to graph. Because especially with the graph you're given the quadrant 3. And so you're going to want to try to keep things in quadrant 3. So you're going to make sure that all your x values are negative.
Okay.
Yeah.
Got it.
So if you want to keep all your x values negative, what x values are you going to choose?
Okay. So what you would do, -4. And then like -8. That
You could if you want to, but does your graph have enough room for that? 1, 2, 3, 4, 5, 6. You're going to want to do negative. You're going to want to do 0 to -6.
-2. To do -3.
And then if you want, just to throw in some funsies, you could do -1/2 as well, or negative,
Okay.
or yeah, whatever you want to do.
I'll just do -1. Seems simple.
Yep, those are all work.
Okay. So you could do -4 plus 4 is 0. So then 3 times 1/2 would be.
Well, what's 3 raised to 0?
Oh, that would just be 0. So it'd be.
Anything raised to 0 is 1.
Oh, right. Okay.
So 0.5 times 1.
Okay. So, okay. What about the 1/2 though?
I changed it to 0.5. Because as we type it into a calculator, 0.5 is easier to work with.
What do you do? Like 0 times.
Well,
the
exponent only goes to the parentheses.
Oh, yeah, so we 1. Oh, so you do 1 times 0.5, which is 1.5.
No, ma'am, it's just 0.5. You keep adding them. It's you keep adding your decimals. You're supposed to add. You're supposed to multiply. So anything times 1 is itself. So it's 0.5.
Okay.
And then 0.5 minus 5 is -4.5. So when x equals -4, 1, 2, 3, 4, y equals -4.5. 1, 2, 3, 4.5. So it's going to go right there.
Okay.
Okay.
Okay. So then for 2, we -2 plus 4, which is 2. So then 2 times 3 is 6.
Well, this is 3 squared. This is not 3 times 2. This is 3 raised to 2.
Oh, shoot. Okay. Okay. So it would be 9 plus. Wait, would it be 9? Wait.
Don't forget to follow order of operations,
So
which
you
is
just
parentheses, exponent, multiplication, division, addition, subtraction. So you just did the exponent, so now you're going to do multiplication. So you
yeah.
do 0.5 times 9, and then you do subtraction.
Okay. So okay. So it's 9. So then it would be 9 to the 4th power.
Well, no, you already did the exponent.
Okay, that's what I thought. Okay.
So now it becomes 0.5 times 9 minus 5.
Oh.
What's 0.5 times 9?
4.5.
Yes, ma'am. So now you have 4.5 minus 5. What's that give you?
Gonna be negative 0.5.
Yes, ma'am. That's what you're looking for.
So then you do okay. So for the next one, 3, you do 3 negative 3 plus 4 1. 3 times 1 is 3. 3 times 0.5 is 1.5 minus 5, which is negative 3. Negative 3.5. And then, so then that is your answer for that. And then for negative 1 plus 4, which is 3. 3 times 3, or 3 raised to 3. 3 times 3 times 3. 27. It seems a little crazy, but I guess it's 27 times 0.5, which is 13.5 minus 5, which is 8.5.
Which is going to be up here.
Okay. Okay.
And then the curve is going to look like this.
Okay.
Yep.
Sweet. Okay, I think like I'll do good, hopefully.
Yeah, well, you know how to do the exponential functions. You know how to convert the logarithmic functions into exponential functions and vice versa.
Yeah.
So, and that's going to be a majority of your test. And then there's going to be a handful of graphs.
Okay.
And with the graphs, you just create the t-chart, choose values that will work, and then plug them in and connect the dots.
Okay.
I'm hoping in your quiz it's a majority of the logarithms and the exponential functions.
Okay.
Because you can do those, no problem.
Okay. Okay.
Right? I think you did a good job with the material. Definitely, if you have time, maybe watch a Khan Academy video on it just to refresh yourself.
It's true. Okay.
On exponential functions or converting from logarithmic functions to exponential functions.
Okay.
Just watch 5 or 10 minutes of it just to refresh yourself. So maybe do it before you go to bed or tomorrow morning on the way to school.
Okay.
I think that would help you.
Okay.
Okay.
All right. Thank you.
Right. You're welcome. See you on Monday.
All right. See you Monday.
Have a good weekend. Bye.